Okay, let's go over the second homework for this unit, which is homework 17. This one covers all of the voting systems that you'll see in this unit. So it has plurality, two-round runoff, instant runoff, agenda, Borda, and Baldwin, everything at once. Problems 1, 2, and 3 are identical. So I'll just do one of them. And you can do the remaining two. So I'll do the first one. Um, for plurality, it's the simplest. You just count the number of top max top votes. So D has 8 top votes, followed by A, which has 6 top votes, followed by B. Okay. And now in under the two-round runoff voting system, since you only look at the top two, in round one, you eliminate, or like after round one, you eliminate uh, C. Yeah, you eliminate B and C. And the top two move to round two. After redistributing the votes, what this looks like is something like this. So you eliminate B and C. So now you have something like A, D, D, A, D, A. Okay. So in round two, D gets 3 plus 8, which is 11 votes, and A gets 6 votes. So D also, sorry, in this one here, you also have C as an alternative. Technically, it got 0 top votes in the first part, so it came in last. Okay. So yeah, D gets in the two-round runoff system, round two, D gets 11 top votes, A gets 6 top votes, so D still wins over A, but B and C are tied for the last position. These are not very good examples because the top two rankings are not really changing from plurality to two-round runoff. So this is not a very good demonstration of how different voting system works. I don't know why they have put the numbers like this, but in general, you could have these switched again. I hope you find some example in problem 2 and problem 3 where you see a switch in the top two ranks. Okay. But yeah, at least this difference is here that B 1 over C in plurality, but B ties with C in the two-round runoff because only the top two matter. Okay. Now let's do instant runoff. So in round one, C is eliminated because it got the least number of top votes. In particular, it got 0 votes. So you redistribute the votes like this. So yes, right now you just eliminate C. And I think the profile looks pretty identical because C was just the second top choice for everyone. So this doesn't really change. Okay. So in round one, you still have B coming in last. So in round 2, B is eliminated. Okay, so after eliminating B, again, this brings you back to this 2-round runoff profile. And again, D wins. So you have D bigger than A, bigger than B, bigger than C, even in the instant runoff. So again, very sad example. Uh, does not really demonstrate how instant runoff changes the ranking most of the times. Okay, I'm sorry about this, the bad example. Again, I hope problems 2 and 3 demonstrate how this can change in general. Okay, so finally, let's do agenda voting system. So the agenda here is you do A versus B first, then you do C versus D. Then the winners from the this first round move on to the final round, and they go for a head-on-head match. Okay, so to compare A and B, let's do A versus B. Um, Eliminate everything else and just look at. Okay, so let's do A versus B here. So eliminate C and D. Okay, now A gets 6 top votes, whereas B gets 3 plus 8 top votes. Okay, so B wins over A. Okay, now let's do the same thing for C versus D. I'll remove this and do C versus D in the same table. C versus D means that you eliminate everything other than C and D. So eliminate A and B. Okay, now C gets 6 plus 3 top votes. Actually, yeah, 6 plus 3 top votes. And D gets 8 top votes. So C wins over D. See how this is so weird that D was the absolute winner under all of these systems, the plurality, 2-round runoff, instant runoff. D was the winner and C came in last every time. So this was the winner, this was the absolute loser. But in with this agenda, if we just compare C and D in a head-to-head match, C actually wins over D. So agendas are very, very skewed. So this was the absolute loser. C was the absolute loser in all of these first 3 systems, and D was the absolute winner. But when you just do C versus D, C wins over D. Okay, so now B and C move on to the final round. So we have to do B versus C now. Let's do the same thing here. Again, to compare B versus C for a head-on match or head-to-head match. You eliminate the other alternatives, A and D. Okay. Now, this time B gets 3 top votes and C gets 6 plus 8 top votes. I'm doing this without redrawing the table, but what this table would be drawn as after eliminating would be the CB, EC, CB. Okay, so C gets 6 plus 8, 14 top votes, whereas B only gets 3. So C wins. So you see how in this agenda, the absolute loser won the final round. And the ranking would now be under this agenda. B versus, C won the final round. So that comes, C gets the first place. B was also in the final round. So it comes in second place. And the other two tie for the last place. Yep. So this is how you rank under this agenda. And you can do both of these the other two agendas similarly. Okay, let's do the border voting system. For that, I will copy down this, here. This time you give points to preferences. So least preference gets 0 points, second last preference gets 1 point, third last gets 2 points, and the top preference gets 3 points here. So let's count the votes for A, or sorry, the points for A. Look at the top row. A gets 6 top votes, so that's 6 plus 3, 6 times 3, 6 votes, and 3 is the weightage for the top preference. So 6 top votes and 3 for the weights for the top preference. Then A does not get any second top choice votes. So this is 0 times 2. Then A also does not get any third choice votes. So 0 times 1. And the last one is irrelevant, but A gets 11 votes as their bottom choice, but that has 0 weight, so it doesn't really count. So this is 18 points. Let's do the same thing for B, C, and D. Let's do B now. B has 3 votes as their top choice. So that's 3 votes times 3 for the weight for the top choice. Then again, B doesn't have any second top choice votes, but B does have 6 plus 8 voters that voted B as their second last choice or their third choice, and that has weight 1. And I won't do the zero again. This was just for demonstration. You never care about the last choice. So this would be 9 plus 14, which is 23. Okay, let's do C. So C doesn't have any voter voting it as top choice. So that's 0 times 3, 0 voters and 3 for the top choice weight. But C does have every voter voting it as their second choice, which has weight 2. This is 6 plus 3. Sorry, let me use orange here. This is 6 plus 3 plus 8. Number of voters voting it as their second top choice, and the second top choice gets weight 2. And then C is not the third choice for any voter. C is not the fourth choice for any voter. So this is it. This would now be 9 plus 8, which is 17 times 2, which is 34. Okay. Finally, let's do D. There are 8 people who voted D as a top choice. So 8 times 3. There are no voters who voted D as their second top choice. So 0 times 2. There are 3 voters who voted D as their second last choice. So that's 3 times 1. And we don't care about the last choice. So this is 24 plus 3, which is 27. Please make sure that you check these calculations. I might have made a mistake somewhere. I may have. I don't think I did, but please recheck the calculations. Okay, so under this voting system, clearly C has the highest number of points, followed by D, followed by B, followed by A. So this is the ranking under the BODA voting system. Okay, so again, you see how BODA at least makes some sense, because C, even though it wasn't the top choice for any voter, it was the second top choice for all voters. So the first 3 voting systems, which ranked C as the absolute loser, did not really make any sense, right? It was not a very good representation of the voters' preferences. But if you assign points and you also consider the other preferences like second top choice, third top choice, and so on, not just the absolute top choice, then you see that C gets the highest weight. This makes more sense to me, at least. Seems more reasonable. Okay. Now let's do Baldwin voting system, which is just BODA voting system done in rounds. So in round 1, you eliminate A. Okay. So round 1, you eliminate A. Now this time, your voter profile would look something like this. Let me just do it by hand. So after eliminating A, you have CBD, BCD, and DCB. Now you assign points again. So last preference gets 0 points, second last preference gets 1 point, and top preference gets 2 points here. So let's do B. B gets 3 times 2 plus 6 times 1 plus 8 times 0, which doesn't really matter. Okay, so this is 6 plus 6, which is 12. C gets 6 times 2 plus 3 plus 8 times 1, which is 12 plus 11, which is 23. And D gets 8 times 2 and 0 times 1, which is 16. So in round 1, you have D, or in round, sorry, after round 1, in round 2, you eliminate the one that had the least number of votes. So eliminate B. Sorry, least number of points, I meant. So eliminate B. So this time, after eliminating B, the voter profile would look something like this. We have C, D, C, D, D, C. Again, you assign points. 0 points for the bottom choice, 1 point for the top choice. And when you have just 2 of them, you just compare the top preferences. That it reduces to plurality. So C gets 6 plus 3 times 1, which are 9 top votes, and D gets 8 times 1, which are 8 top votes. So C wins over D. So D is eliminated in this round. Okay, now the ranking would be under the Baldwin voting system. C wins the last round. D was eliminated just before that. B was eliminated just before that, and A was eliminated in the very first round. So this is what the Baldwin ranking looks like. Again, very, very bad example. Comes out to be the same as the VOTA. This is not true in general. Okay. Problems 2 and 3 are identical. So try them out for yourself. Let's do these true and false statements. So if you have elections with exactly 2 alternatives, the social ranking under BODA always equals the social ranking under Baldwin. That is true because you don't need to move to other rounds. Baldwin is just applying BODA in rounds. And if there are only 2 alternatives, you're not eliminating anything. So in fact, this also equals the social ranking with plurality. Okay. If you have exactly 3 alternatives, then the ranking under BODA equals the social ranking under Baldwin. This is false in general. I hope you find a counterexample. Find an example to show this in problem 2 or problem 3. So I hope in one of those, your rankings under the BODA and the Baldwin system come out to be different. Unfortunately, every example that I'm using as a demonstration has the same rankings under most of the systems. Okay. The third one says that if an alternative comes first under plurality, then it can never come last under instant runoff. This is true. because if it comes first, then it's definitely not under plurality, then it's definitely not eliminated in the first place. So, I mean, after the first round. And the one that's eliminated in the first round comes in last in instant runoff. So this is true. If an alternative comes first under plurality, then it can never come last under instant runoff. Yep. Because they would not be eliminated after the first round. Okay. However, if you have an alternative coming in first under plurality, then they can actually come last under order. Let's see if this was an example to demonstrate it. For plurality, D came in first, but Boda, okay, D came in second, not last, but it can happen. Sorry, just running out of good examples here. But yeah, it can come last under Boda. Finally, given any voter profile, it is always possible to choose a particular agenda so that any alternative can win. Not really. Sometimes you can do this, but let's say if you have only two alternatives, there's only one possible agenda. And the winner is fixed. So you can't really manipulate it in a way that any alternative can win. This is false in general, but sometimes you can do that. Okay. For problem 5, you're given this voter profile and you want to draw agendas so that the social ranking is um, something of your choice. So the first one wants A to win over B to win over C. Note that whenever you have just three alternatives, this means A and B compete in the final round and A wins. So you have something between A and B, and A wins the final round. A and B are the finalists, and C is one of the bottom ones. So you can either have A and C compete with each other, or B and C compete with each other. Let's see, in a head-on head match, if B wins over C. Let's see if this is correct. This could also be A versus C, but let's see if B versus C works. So yes, this works because in a head-on-head match between B and C, you eliminate A. So B gets 32 plus 34 top votes, and C only gets 36 top votes. So B definitely wins over C. So this is one good agenda like this. Okay. And I think similarly, we can do these. So B needs to win over C, needs to win over A. So the finalists are B and C. B wins, and A can compete with either C or B in the first round. So let's see if this agenda works. Let's see if this is correct. So A versus C, C should win. Okay. So to do A versus C, let's eliminate B. Now this time A gets 32 top votes, but C gets 34 plus 36 top votes after transferring these votes. Okay, so clearly C wins. And finally, let's do an agenda where C and A are the finalists. C wins over A, and A has to win over B, so you can just do A versus B here. And I think this would work. You can check for yourself. Okay. Now this last problem is very interesting. This time you are given a voter profile where you have an unknown number of voters having the preference D, A, B, C. So there are X number of voters here, and you need to find the values of X so that the social rankings under different voting systems come out to be some particular rankings here. So the first one is that you need to find the value of X so that the social ranking under the plurality system is this. So under plurality, you only look at the top row. So C and D tie under plurality. So that means X needs to be 4 because C and D need to have the same number of top votes. Okay, so X is 4 in this case. For the second one, you want the ranking under instant runoff to be D, D, C, A. So that means A is eliminated in round 1. So A gets the least number of top votes. So X, which is the number of top votes for D, must be bigger than at least 2 because otherwise if D gets less than or equal to 2 top votes, then D would be eliminated in round 1, which would put D in the last place. So X needs to be bigger than 2. Okay, now in round 2, after A is eliminated, we have, after eliminating A, we have 2, 5, 4x, and you eliminate A. So that gives you B, C, D, B, C, D, C, B, D, D, B, C. Okay. Now we want C to be eliminated in round 2. So C needs to have the least number of top votes. So B has 7 top votes, C has 4 top votes. So X must be bigger than 4 for for D to not be eliminated in this round. Okay. Now round 3, after C is eliminated, has a profile something like this. So you have 2, 5, 4 X, and you have BD, 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 and DB. Now B, sorry, let me write it more clearly. So you have, and make more space here. So you have 2, 5, 4 X, B, D, B, D, BD, and DB. So B has 2 plus 5 plus 4 top votes in this round, which are 11 top votes, and D has X. We want B to win, so X must be smaller than 11. Okay, so now anything that satisfies these conditions, where X is bigger than 2, X is bigger than 4, but X is smaller than 11 would work. So let's take X to be 9. This is between 4 and 11, so this should work. Okay. Now let's do a calculation where under the Boda voting system, this is the social ranking. Okay. So let me copy this down here and assign points to it. We assign points to preferences. 0 points for the bottom preference, 1 point for the second least preference, 2 points for the third least preference, and 3 points for the fourth least or the top preference. Okay, now let's calculate points for all of these. So A has 2 times 3 points plus 5 plus X times 2 points plus 4 times 1 point. So again, 2 top votes for A, and the top votes have a weightage of 3, so 2 times 3. Then for A, you have, sorry, okay, so this was this component here. The orange one is 5 plus X number of votes for A as the second top choice. So 5 plus X times 2 for the weight for the second top choice, and then 4 votes for A as their second last choice. So this is 6 plus 10 plus 2x plus 4, which is 20 plus 2x. Okay. Now let's do the same thing for B, C, and D. So for B, 5 voters voted B as their top choice, so 5 times 3. 2, sorry, 2 voters, so 2 plus 4 voters voted B as a second choice, so 2 plus 4 times 2. And X voters voted B as their third choice, so X times 1. This would be 15 plus 16 plus X, which is 31 plus X. Let's do the same thing for C. So 4 voters voted C as their top choice, so 4 times 3 plus no voter voted C as their second top choice. So 0 times 2. And then 2 plus 5 voters voted C as their third choice. So 2 plus 5 times 1. This is 12 plus 7, which is 19 points for C. Finally, let's do D. X voters voted D as their top choice. That's X times 3 plus no voter voted D as their second top choice. So 0 times 2. And no voter voted D as their third top choice. So 0 times 1. This is 3x. Now we want the ranking in a way that B has the highest points, followed by A, followed by C, followed by D. So we want 31 plus X to be the biggest, followed by 20 plus 2X, followed by 19, followed by 3X. Okay. So let's solve these inequalities. Sometimes you can just do a trial and error. Just maybe have 3 as, let's say, if 3 is 6. Okay, first, or let's do it properly. Okay, let's do this pair of inequality. So 31 plus x bigger than 20 plus 2x. This means that 31 minus 20, which is 11, is bigger than x. Okay, so x needs to be smaller than 11. Then let's do the other pair. So 20 plus 2x bigger than 19 means 2 bigger than negative 2x. Yep. Sorry, 1. This should be 1. 1 bigger than negative 2x. Or this would clearly always be true because x needs to be positive. So we don't need to worry about this. Finally, 19 should be bigger than 3x, which means that 19 over 3 should be bigger than x, which means that this is something like 6 point something, 6.33, I guess. Okay. So yeah. So let's take x so that it satisfies all these conditions. So let's take x to be 12. Or sorry, let me see if I'm doing something wrong here. So 19 needs to be bigger than 3x. So x needs to be smaller, not bigger. Sorry, I read the inequalities the other way around. X needs to be smaller than 6.33. So let x be 6. Okay, so this way, this comes out to be 31 plus 6, bigger than 20 plus 2 times 6, bigger than 19, bigger than 3 times 6. And you verify that this is correct. So this would be 37, bigger than 20 plus 12, which is 32, bigger than 19, bigger than 18. So this is correct. So x equals 6 works, or anything less than 6. So this is how you do such problems.